All right, it's 10:05, 10 and 5, and I think we can already begin with the webinar. So let's just introduce ourselves. Manon, if you may.
I am Manon Lessard. Some of you may know me as May Lessard. I am a Wi-Fi geek. I love Wi-Fi. First and foremost, that's what got me here. I happen to be CWNE number 275. I'm a network admin for a large university in Quebec City, Canada. I'm also a tech editor, an author, and a speaker. And I love everything that has to do with Wi-Fi, so I couldn't resist when Elliot asked me to give him a hand doing this webinar. And here's Elliot.
Thanks a lot, Manon. I think we were having troubles with the GoToWebinar. This platform is new to me. Sorry, everyone. Well, as Manon says, I'm Elliot. I'm the hotspot pumpkin with the spirit of Halloween. Here, Manon is a wireless vet. And, well, let me just introduce myself. I've been working for Wi-Fi, for the Wi-Fi industry for 4 years already. I have some certifications, as you may see in the slide. I have also been teaching wireless networking classes for Cambio Networks for 3 years already. And I'm also in charge of the education and trainings here in Sama Wi-Fi. So these webinars and the courses that we give to everyone are mostly my responsibility. And just as Manon, I'm also a geek of the Wi-Fi industry. I love Wi-Fi, everything related. I'm also a security geek. And well, I'm really happy that Manon is here with us. I hope no more technical issues will happen. If not, I think I can already see everyone's chat. Just please let me know. And well, let's begin. All right, guys, let's begin with introducing you to the topics of this webinar. We will be focusing this session for these 3 main topics: understanding common Wi-Fi problems, some tips and tricks, and at the end of this presentation, we will show to everyone a small demo of how to design a wireless network for office environments. I prepared a video. I hope we'll be able to meet the schedule. And well, before moving on, I have to say that before I was coming to work today, this presentation was scarce, but the ghosts of Wi-Fi. So you might be looking at some spooky things during the webinar. Don't freak out. It's just that the ghosts of Wi-Fi will be demanding us to teach us good Wi-Fi practices, and if not, you'll be scared. So, oh no, I just don't get too much scared. All right, let's begin. Understanding common Wi-Fi problems, first topic. These are the main things that we will be reviewing throughout this chapter, this topic. I gather most of the most common problems that people tend to face in the Wi-Fi industry when designing for office environments, like creating a good channel design, understanding bad hardware installations, understanding the impact of low data rates in the corporate environment, also understanding client capabilities and how they affect the overall throughput of the network.
So you guys, I'm sorry to interrupt you, Elliot, but you have to understand, and if you're new to the industry, this is news to you. If you're not, then you know that those four items are part of the basics of Wi-Fi, regardless of location. So, good channel design, bad hardware installations, configuration things that tips that tweaks like, playing with low data rates and all of that, they can really make the difference between something that's performing well and something that's not performing well. So you wanted to talk about creating a good channel design.
Sorry.
How about you show us an example, Elliot?
Yeah, sorry, this let's go forward. All right, here I'm presenting to you two applications, two tools that are quite popular among Wi-Fi engineers. Before moving on, I want to mention that this webinar is not for experienced people, it's for everyone. So if you guys happen to have already experience in the Wi-Fi industry, that's okay. You perhaps know something new in this webinar, and if not, well, it's your lucky day because today we'll be looking at the most common problems. So let's begin. As you can see here in the left, it's one of the most popular apps for Android is Wi-Fi Analyzer. It's an app that let us see the channels and the wireless networks that are in the environment. It's a way for us to find the best channel that suits our needs just by
So,
looking at which is the most the less polluted one. And well, in the right you may find that I'm also adding an image of Ekahau, and I'm adding an image of Ekahau because it's a more professional tool. Wi-Fi Analyzer is free, and well, Ekahau it's a professional tool that allows us to look at the wireless networks in a better way, and not also at Wi-Fi, but also noises and interference that may not be a wireless Wi-Fi signal, but maybe introducing some noise to our network.
so the tool on your left is what you can run on an Android phone. There are several versions of this kind of view. This is a Wi-Fi friendly view of the spectrum, as Elliot said. However, it's also displaying the power to which it can see the signal, and it can show you the width of the band that's in use. And usually you can see that for both 2.4 and 5, depending on the capacity of your phone. The Ekahau tool, as Elliot said, will show you it's a full-fledged spectrum analyzer in the sense that it will show you patterns of radiation that may impact, because remember, Wi-Fi is unlicensed bands, and unlicensed bands can be used by anything. So you will see all sorts of things that are Wi-Fi and some other things that are not Wi-Fi.
Exactly.
For example, cordless phones, microwaves, wireless cameras, um,
Air
microwave. I mean,
conditioners, Bluetooth, Zigbee.
and they are not Wi-Fi, but they can have a definite impact on the channel plan and on the usage that you can get out of your wireless network.
Exactly, because they introduce noise, and that noise will end up affecting the overall network throughput. But we'll look into that in the further slides. All right, referring to the previous tools, it's important to build a channel plan for every office environment. one of the most common errors that people that are not wireless engineers tend to have is that they just leave the automatic configurations of their access points, and because of that they end up with wireless zones or cells sharing the same channels, which is something that ends up as co-channel interference in every office. Also, something that tends to happen a lot with some wireless vendors is that 14 megahertz channels are live open and they are working in that band, and that just end up causing more trouble with the neighbor APs. Now referring to the 5 gigahertz band, you may see in this image that we have way much more channels than the 2.4 gigahertz band. We have more choices. We can even use 14 megahertz channels without introducing noise to adjacent channels because of the way the 5 gigahertz band was assigned. But the problem here, and is one of the most common wireless problems, is that when people that do not know about Wi-Fi just leave in defaults their access points, they end up using 160 megahertz channels, and that's just suicidal in a high density environment, because the wider the channel, the more you're exposed to noises and interference from other channels. So one piece of advice that I like to give to everyone in this webinar is that when possible, in high density environments, just try to use 40 megahertz channels. It's possible 80 might work, not in really high density deployments, but never use 160 megahertz channels for the 5 gigahertz band. It's really not worth it unless you're alone in some kind of facility. It's really not worth it. You end up way too much exposed to noises in the network. And as for the 2.4 gigahertz band, the problem with this band is that we only have 3 channels that do not overlap, and that's a big problem because we have to pray to have this kind of cells deployed throughout the facility. But the problem is that neighbor businesses, the people from floors above, floors below, they just might not be able or be willing to change their channels to have this kind of cells, smaller cells that do not overlap with the neighbors' channels. And well, that's one of the first problems that would come to face whenever we have an AP set to either default configurations in an office environment. I'm not sure Manon would like to add anything else.
Well, that's some very important stuff. Let me remind everybody that 2.4, some people could argue that, oh, I'm going to use 1, 5, 9, and 13 because I can use 13 in my environment. Yes, you can do that, but most devices are set to support as non-overlapping channels 1, 6, and 11. So what's going to happen is that your device is simply not going to connect. So my suggestion, especially if you're working in, Mexico and Central and South America are kind of like us. Canada, we have to deal with the fact that most of our stuff comes from the States, right? So sticking to 1, 6, and 11 is the safe way to go. 40 megahertz, you don't have 2 channels that won't overlap at all. And remember, it's not just a question of avoiding interference, but it's also a question of getting the channel to be cleared. Going back to your explanation about 160, to be able to use your 160, because you can say, oh, I'm using 160 at home. You may think you're using 160, but really, are you clearing the entire 160 megahertz band to emit? Are you really gaining anything from it? So yeah, I would really stick to 20 megahertz and 2.4. Stick with 1, 6, and 11 and 5 gigahertz and very high density. Stick to 20s. If it's mid-range, go to 40s, but avoid 80s and 160s if you can. That's really important.
Yeah, you see, something I have found in most wireless corporate environments is that not even much clients even support 160 megahertz channels. That's something I wanted to mention because it's not even worth trying, in my opinion. But anyway, let's keep going.
Just a thought before
Yes.
we go. I'm sorry, it just occurred to me. Um, One thing that you want to do before you deploy, just in order, because nobody lives in a bubble. So before you deploy anything, try to do a quick exit survey to see what's in use, um, what's the surrounding channels and everything that's related to that. It's going to help you to create that good channel plan. And 5 gigahertz, if you can use them, use DFS channels, and also try um, to space your channel so that you're using 40 and 48 and you're skipping one, just to make sure that you're really isolating as much as possible from the other cells.
Yeah, that's important. Okay, this is something I wanted to show everybody. This was a deployment I was surveying like 2 years ago. And just as Manon mentioned, it's important to do a previous survey of the facility you'll be installing your Wi-Fi equipment, because you never know what's going to show up. For example, this is something that happens often in my experience. Some non-Wi-Fi devices, just like this air conditioner, will generate wireless signals that precisely will not be of Wi-Fi, but will be in the environment anyway, and that's just ends up as noise. For example, in this place, it's a place located in Mexico City. In the conference room of this enterprise, people used to have an air conditioner really close to the window of this conference room. And you see, the problem was that it was introducing lots of noise, just as you can see, minus 43 dBms of noise. That's just crazy. It's way too much noise. And this was happening in the 2.4 gigahertz band. And this was a time when not many devices were 5 gigahertz compatible. So what these guys end up doing was to remove the air conditioner, because they needed Wi-Fi in that area, and the 2.4 gigahertz band was just not working because of the high levels of noise. So one good advice and one of the problems that I happen to see in the industry nowadays is that people often don't do a pre-installation survey, and that's a problem because some of these things might show up, because Wi-Fi is the last thing you add to the facility once everything is installed. So just be aware. Noise is present everywhere.
And you know, this confirms exactly what I was saying, that you really need to, even if it's just a quick sweep, like not going through every single room, you're going to get an idea of what's in the environment, because it would be living in a bubble to think that there's nothing in the air. And sometimes you're going to find non-Wi-Fi devices, and sometimes it's going to be Wi-Fi devices. I found in a pre-survey sweep, I found a connected oven. I found a connected dishwasher. You find all sorts of stuff that you didn't think was turned on. I mean, I find printers all the time, and that brings me to remind you that uh, those guys don't really think it's a big deal. But the
It
more
is a big
people
deal.
the more people that are using the band, the less people can use the band. In the example that Elliot is showing, it's an AC unit. It doesn't speak Wi-Fi. The nice thing about Wi-Fi is that it can be very polite. Everybody's gonna take their turn and wait for their turn to speak. Um, the air conditioner just makes noise. And if you look at the noise level that you have there and the power that was emitting at, um, for sure, someone that was trying to get the band would never be able to get it.
Yeah,
It's
that's
got your clear channel assessment to tell you that, okay, it's your turn, you can speak.
exactly. It's just too much noise. Minus 80 dBms, minus 85, that's tolerable, but minus 43, that's
Yeah,
just for Wi-Fi.
ideally, minus, well, neg 82 is the second level. So, yeah, you want to try to avoid something that's going to generate more noise than neg 82, ideally.
Yeah, I agree. Okay, let's keep moving. Oh god, another ghost. We better teach everyone good Wi-Fi or we'll be corset for our lives. Oh, it's gone. Okay, one of the problems that also happens a lot in corporate environments and is for mostly when people do not know about how Wi-Fi works, they just like to give an SSID to everyone, a wireless network for everyone, for the admin department, for logistics, for marketing, for sales, just an SSID for everyone because the IT administrator has an SSID in attached to a VLAN that goes to a switch and he's sectioning the network in order that some people uh, from every area don't see the resources and the servers from those other areas just as a security measurement. But the problem is this, when you have employees just going around the facility, the place, all around, and you want to let them join your network wherever they are and they have a necessity just for them, you must just end up causing more trouble for the network throughput and speed because for people new to Wi-Fi, there are these frames called beacons that just come out from the access points, 10 beacons per every second, and those frames take airtime. They have to be released in a schedule so that we can see the networks around us. And just as you can see here in this Excel sheet from Revolution Wi-Fi, if you add more than 3 cities, you end up taking way too much airtime from your clients just for managing those beacons. Also, depending on the protocol of your IP, those beacons might be slower. For example, if you have like legacy APs, 802.11b APs will speak more slowly and will release those beacons way too much slowly than an AC access point. And because everyone has to contend for the medium, you will just end up with too much airtime just dedicated for those beacons. So 3 SSIDs, that's okay. 4 SSIDs, that's also okay, but I wouldn't recommend it because of what I have explained before. Here in this sheet, you may be able to see in a more detailed manner if you guys look to the link that I have written in the slide, how every beacon tends to affect the network.
So these beacons, they always travel at the slowest supported speed on the network, and they're sent out every 102 milliseconds. So for each SSID that you're supporting on your infrastructure, if you want it to be available everywhere, you're going to spend some very important airtime that you could be using for good put. You could use that airtime for doing business, for accessing devices faster. Reducing the number of SSIDs is a simple step to avoid wasting your airtime, because there is one thing that is finite, and that's the airtime. You won't be able to get more of it. You just have to maximize it, and that's one of the ways.
Totally.
By the way, if you're looking into SSIDs as means of security, I would recommend, if ever you have a radius server solution like Cisco ICE or something like that, that you look into securing and segmenting your traffic through the use of the radius server instead of making it through the use of different SSIDs. That way you can send accounting to a specific VLAN, you can send engineering to another one, give them different rights, give them different access levels, and you're only using one SSID really.
Yeah, you see, I have also found in many vendors nowadays, it seems like everyone is deploying this, and it's something called EPSK, which is like a way around the radio server. And these things, well, this technology also helps to locate everyone or other clients in a specific VLAN, but not by using a radio server. It's something that I have seen with Arrowhive, and I think that Campion also supports it. Well, let's keep moving. Okay, understanding bad hardware installation. This is a really important slide, and it's important because people don't tend to be aware of how every one of these examples is affecting them. And well, let me just show you so that you can get it better. In here, the first example, as you may see, we have omnidirectional IPs. These are some ones from Cisco. And well, the trouble here is that when you place an access point that is meant to radiate omnidirectionally on a wall, it's not going to radiate omnidirectionally, because just as you may see in this picture, you are rotating the azimuth radiation pattern, the full extent of the wireless network of this access point, and you're just placing this donut in a vertical manner. So the access point is not going to reach as further as it's meant to be in in a room or any facility that you have. Instead, it's going to rotate over himself and under himself. And well, I'm not sure if people would like to have a Wi-Fi under them. Sometimes it's for the floors below, but if the clients don't have the power to answer back because of the ceiling, that's just a wrong example of bad AP placement.
And it could happen that you cannot put your AP on the ceiling, if ever, and you happen to use external antennas on your AP. You can very well install it on the wall. Only the radiating element is in the correct angle. Right here in the first picture, the radiating element is not, it's like a donut on its side. Stick a donut, you can see the hole, and you can see the little LED light through the hole. That's the coverage that you're going to get. So, you know, if that AP is installed on the last floor of a building, you're grilling seagulls, and you're also grilling the guy underneath, but you're definitely not helping the case for for those cameras and for the people that are staring in front of the AP.
Totally.
And
okay.
did you want to go over the APs in hallways?
Sure. Let me show everyone what's a problem with the big deal with APs in hallways. You see, a radio frequency, it's pretty much like light. It bounces just like light does in mirrors. And when you place an access point in a hallway, if the hallway has really stiff materials, if the hallway is made of really stiff materials like concrete, metal,
Brick, a really thick sheetrock. If
yeah,
ever, basically what you're, I'm sorry, I'm going to cut you off on this one. Those are my favorite installs. So basically, you're giving very good service where the user is not. You want to get close to your user, and you want to give the service to your user. Not only are you exposing yourself to a zone where your signal is going to get attenuated because it doesn't go in the room, you're also exposing yourself to potential trouble because the APs are going to see each other because they're all lined up in the hallway. So especially when you're using dynamic channels, you're going to run into issues because the APs are gauging their power and selecting their power based on the other APs they're seeing. If they're seeing each other, they're going to turn the power down, and your user that are standing in those rooms will not get as strong a signal. That's one of the problems. That's one of the many problems with that install.
Yeah. And just as you guys can see in the picture, the RF just bounces within the hall, and it will not end up reaching your clients well. So moving on.
Also, just before you move on to the other picture, there's way too many APs there. There's like what? There's 8. They shouldn't be this close to one another. And even if one is servicing 2.4 and the other one is servicing 5, you know, and the two, you know, you're skipping one before you reuse the 2.4. They're way too close. Even if they're not on overlapping channel, you're gonna mess up their signal.
Yeah, the 2.4 gigahertz band will have a hard time in this kind of environments. That's just another bad Fi practice. Having APs too close to each other, that's just messy. And problems with dynamic channels, just as Manon mentioned, will end up occurring. Okay, moving on to the next picture. I have seen this in many offices. They just don't want the access point to be visible, and that will just end up causing more trouble, because as you can see in this picture, hiding the access points will just attenuate more the APs, because they are not able to see their clients. They have obstructions on their way, and because of that, the signal strength just gets lower, and that ends up as a slow network from the client perspective. I'm not sure if you have dealt with this before, Manon.
Oh, I have so many of them. It's almost magic, you know. Sometimes the installers, it's almost like whenever they see an AP, they feel the need to hide it. So in that picture, from what I can see, and it's not too clear, but in that picture, it seems as though those are metal tiles. So you've got a whole bunch of reflection, and that pipe that we see really, really, really close to the AP is going to cause some more issues. Obstruction very close to the AP is especially to avoid. And I mean, you know, they're APs. You can get skins for them. You can get special enclosures for them, but please put them close to the user. You want your good Fi close to the user. That's what you really want.
You see, some of the biggest enemies I have faced when dealing with bad office deployment are interior designers. They for some reason just they don't want to see any APs around. So that's another enemy to look out for whenever deploying a new wireless network.
And you know, nowadays there are so many solutions, from custom tiles to, as I said, skins that will camouflage your AP, and nobody will notice that, you know, it's not a stone, it's an AP, to special mounts, to enclosures in a floating floor, where you can actually have a hole in the floor and install your AP underneath the floor so that nobody will see it. There are so many other options, but to hide it behind a pipe in the ceiling like that.
Exactly. All right, better keep moving or we get spooked. I did not see that one coming. All right. Understanding low data rates. For people new to the wireless industry, I like to present to them what we now know and refer to in the industry as legacy data rates. And well, these were the speeds, the overall speeds at which Wi-Fi started back in '99. And well, nowadays these are considered way too slow for us to work. Sorry, Manon.
It's 97, not 99.
Oh yeah, no, but the V was in '99, no, and the 802.11 without letters was in '97, right?
Yes.
Okay, just checking.
I apologize.
It's okay. As far as I remember, it's 802.11a and B were released in '99, and before that there was 802.11 without any letters in '87.
Yes.
And that thing even used, yeah, that thing even used infrared communication, right?
Yeah, and it was frequency FHSS, SS, so frequency hop spectrum. And it was 1 and 2 megabits data rate, so it was really slow.
Yeah, I was way too young for remembering that. I think I was like 5 years old.
I will not mention my age because you will say I'm old. I've been doing this for 17 plus years, so Our first deployment was 802.11 prime, and then we had 802.11b, GA, N, AC, and now AX. Soon, I hope.
You have walked a long way in the Wi-Fi industry. Well,
So,
moving on. Yeah, moving on. One of the problems that people tend to face with the legacy speeds is that, first of all, these speeds are just not as fast as clients require today. Also, these data rates tend to cause roaming issues on the network overall, because something that many people that are new to the industry do not know is that the client has the last word whenever it wants to roam. And if the client is really bad at taking decisions when roaming, the client will stay connected to an AP, even if it's giving 1 megabit per second of throughput and speed. And that's something that we know in the wireless industry as a sticky client. It's a problem that happens very often in my experience, and mostly with some cheap Android phones, the ones that are not as advanced. These devices tend to take bad decisions when roaming. Although they have APs that are way closer to them, they tend to stick to the first AP that they connected to, and they will remain there until they don't get any more signal.
so one thing that's bad is the sticky client situation. You're always dependent on your clients. Now, if possible, it is common practice and, well, actually best practice in the industry to try to disable as many of the B rates as you may. There are devices that will only support B rates if you have symbol scanners, if you have badges. You have to check if your clients support it, but cut as many as you can so that you can save some good airtime that could be given back to the user. And remember, those beacons only travel at the slowest speed you're supporting. So if you choose to support B rates, maybe choose to cut off 1 and 2 megabits and keep 5.5 and 11. Worst comes to worst, so that you can still support yet gain back that airtime that's just waiting to be used and being wasted.
Yeah, as a piece of advice, I would like to tell a story that happened to me. I was deploying a wireless network in the United States, and I had this great idea of disabling the legacy data rates so that everyone could perform better roaming. And something that happened in that place, these guys didn't have handhelds or remote scanners, just normal office equipment, but they had a guest network. And that guest network was also used by the cleaning personnel. And something that happened when I disabled those low data rates, it was that people were not able to connect to the wireless network anymore, because some Android phones, some really Chinese phones, these phones start transmitting at the 1 megabits per second data rate, and they go on after that. And since they were not viewing the legacy data rates, clients were just not able to connect. So as a piece of advice, it's good to disable low data rates, just perform several tests before disabling them, because you might end up leaving someone without any wireless network connection. Okay. Now, moving on, Manon, would you help me on this one?
Yeah. So
I'd like to know your point of view.
So as I've said many times already, you are always dependent on the devices that are connecting to your network. The very last decision is going to be made by the client, whether it connects using 3 spatial streams or 1 spatial stream or an old B rate or what have you. So if you have to deploy a new network, whether it's a green field or a brown field, that is, if it's a place where they've been living under a rock and there's no Wi-Fi around it, or a place where you have to replace the current infrastructure, know the device you have to face. If there's a lot of smartphones, smartphones nowadays use only 1 spatial stream. The reason being that when you use multiple spatial streams, you are spending precious battery resources. So since we want to keep our phone away from the charger as long as we can and use them for as long as we can, the most portable phones have 1 spatial stream antennas. Now, the secret recipe of a well-performing Wi-Fi network is fast on, fast off. Try to make sure that you have the highest low speed possible. Try to make sure that your devices, you know the mix they have, you know the drivers they're running as much as you can, and try to take the decision based on that. It's useless, and I always have fun. I don't know if you have Best Buy and Future Shop in Mexico. Future Shop no longer exists in Canada, but
no, Future Shop, no, but Best Buy we do.
yeah, so the Best Buy guys are gonna tell you, oh, you need the latest router and you need this and that because you know you want to go super fast on the Wi-Fi. Yeah, but what about the uplink? What about the devices that you're gonna use? So it's really a question of balance. If you know that you have a high performing pool of equipment and a good internet pipe and a good performing network to the latest standards, then yeah, fine, it's going to be blazing fast. But don't forget that someone may walk in with a 1 spatial stream smartphone, and he's going to be incorporated to the device mix, and that means that there's going to be a little bit more overhead. If you have devices that you know, since most standards are retro-compatible, there are some mechanisms in the newest standards to make sure that they can cooperate with legacy data rates. So that's going to cause overhead on the network. That's going to waste some usable airtime. So, you know,
yeah,
try
something
to
that people, yeah,
find the best recipe for your mix of devices, of technologies, of capacity. And remember, wireless is not only wireless. There's always a wired part. So, you know, I remember I've been to conferences where the wireless was great, but the internet pipe was,
yeah,
I'm not gonna
not
say the word,
not
but
always the Wi-Fi is to blame.
very, very slow. And then the Wi-Fi gets the bad press. It's not a wireless
Yeah.
problem. It's an internet backbite problem. So
Sometimes it's even a capacity problem when you have way too much devices, just as people can see in this image, as you mentioned, faster devices, the ones with more spatial streams, tend to talk fast. So if you had per se a given app that required 10 megabits per second, faster devices, the closest the closer they are to the APs will talk faster, but devices with less spatial streams, if they are away from the access point, they will spend more airtime, and that airtime will not be available for other devices unless this client is served. And that's something why I think vendors nowadays are implementing airtime fairness, which is not part of the standard of Wi-Fi, but it's like a way around this problem. Okay, let's keep moving. We are almost reaching the hour, and we have a few more topics to discuss.
So if you don't mind, I'll take this one.
Yeah.
There is an organization that's called the WLA, of which I am part. It's the Wireless LAN Association, and we are defining standards for wireless professionals so that we all have a common set of practices. And these tips and tricks are part of the things that we recommend. So start by defining the network objectives. Begin. I often say that as a catchphrase from an old business book called the Seven Habits of Highly Effective People. So begin with the end in mind. You want what? You want to connect these devices. You have these technical risks, constraints. You have these business risks and constraints, and go ahead and design according to those specifications. And get things formalized, get a floor plan, get all the information you need before you start, where the closet's located. All of those things are things that are going to help you do a better plan, because you may want to put an AP at the far right corner, but if the wiring closet is at the left, the down left corner, maybe you won't be able to reach it. So those are all things that you should consider.
Yeah, I also start by defining with the client, the end user, if we'll be working for coverage or capacity. And that's a concern that always happens around, because having coverage in Wi-Fi is easy, but just as you mentioned, you might end up with a client too far away from the access point, and that user is going to end up complaining about the bad Wi-Fi. And that's just something we would like to avoid.
The coverage approach was the approach that we had several years ago, actually in 2003, 2004, when we first deployed our institutional wireless network. We had a situation where we didn't have much budget and we wanted to cover the entire campus. But that means that our clients were not getting the best speeds possible. Whereas today we want to deploy for capacity, where everybody is going to get a small cell and be fast on, fast off.
Exactly. One piece of advice I can give to people that are new to Ekahau, it's that Ekahau has its profiles for coverage, which is basic connectivity, or capacity, which is mostly related to voice and data profiles. Well, moving on, something I want to tell everyone that is listening to us is that these applications here on the left, these are all a capacity concern. These kinds of applications, such like gaming, Twitch, for example, voice over IP, Skype, even voice over Wi-Fi, which is not available all around the world. These are sensible applications that need to be served constantly by the APs. And if you have like a help desk that has gone wireless, you have several users that will be using Skype or some voice over Wi-Fi
Teams,
technology.
Skype, or Jabber if you're a Cisco
Exactly.
user. And since you're talking about voice, you're talking about if you have a delay above 150 milliseconds, you're going to hear the difference. Your ear is very sensitive to these latencies, and if there's variation in the delay, you're going to end up having jitter problems. So you have to be aware of the client's throughput need and also the application that they're running.
Exactly.
And for that matter, and I'm kind of, I don't know if you have a slide about that, Elliot. Andrew Van Nage, who's also known as Revolution Wi-Fi, we borrowed his very famous capacity calculator and SSID calculator for a previous slide. He has a very good capacity planner. Now, remember that you'll be able to design with capacity in mind, but testing capacity will require that you have the actual people on the floor. You can't simulate a capacity test. It's going to be very hard.
Totally. Also, something I want to advise to our attendees is that whenever designing for voice applications, try to avoid DFS channels because the roaming to those channels it's going to take way longer than non-DFS channels. So a good practice would be if you're really going to use voice over IP applications to try to avoid those channels if the clients are going to be roaming all over the place. All right, moving on. Something that Manon was also saying is always consider your client devices when designing your channel plan. And this is something that I have seen in every country that I've been, is that in huge deployments, huge office deployments, such like the corporate offices of Coca-Cola, people of IT tend to use every single channel that they have available. And the problem with that is that you're always going to have, in this kind of environments, a mixture of clients. Mostly if you allow your users to bring their own devices, a BYOD scheme. And the problem with that is, just as you can see in this webpage of Michael Bano, not all your clients are going to be able to listen to every single channel in the 5 gigahertz band. One piece of advice that I can give to our listeners is that bookmark this page. It's really important. It's quite useful for every wireless engineer. It helps us to be able to create good channel design with our clients on mind. Because, for example, this channel 144, this channel in my experience tends to have lots of problems because it was added to the standard, I believe, in 2014, 13,
Yeah, it's a
and some legacy, yeah, and some legacy devices that are even AC capable, they don't support it. So that's one less channel for you. And just as you can see, some PCs, even some phones, for some reason, some devices don't support the DFS channel. So the best piece of advice that I can give to everyone here listening is always know your clients. They are important, and if you do a good channel design, it would not matter if your clients are not able to listen to those channels.
So we keep mentioning the DFS channels. So DFS channels are the terminal Doppler channels. So they are used by some weather radars, especially in Canada, for specific transmissions. And and they're also available to use on Wi-Fi. Now, if you want to use them, the one thing that you have to know is that if ever they detect a radar event, which is a burst of energy on the frequency for a specific amount of time, the AP has to be able to move to a non-interfering channel. So this is why a lot of devices do not support them. Now with AC and with AC exploiting a lot of the 5 gigahertz bands, we do use a DFS channels, but we use them sparingly. I would strongly recommend, depending on where and who is your regulatory authority, to make sure that you can use them and what the conditions are for using them. And also, as we said, refer to client.mikealbano.com. Mike's an awesome guy. He does this just to pay it forward. If ever you happen to have a device that is not listed in there, that you can provide him with a trace, wireless capture, so that he can see what are the capacities, he'll add it to the list, and he's going to be very happy to get your contribution. So I think he has the instructions just in case you need to send those informations to him.
Yeah, and I think I don't have a slide with the DFS channels in a picture, but just for that the guys who are listening to know, these channels go from the 52 channel all the way to the 144. So just keep in mind that in that range of channels, you guys need to be aware of that consideration, that these are DFS channels and they work slightly different than our channels. Okay, coming to this slide. Once your design in 5 gigahertz work, you may start designing for 2.4 gigahertz. This is an advice that I have heard mostly all around the world by many wireless designers. And it refers to this. You're going to have way much more channels in the 5 gigahertz band, so you can use those channels for your wireless network design. And also you have to keep in mind that the 5 gigahertz band, since it goes faster than the 2.4 gigahertz band, the reach, the how long can these channels reach to the whole facility is going to be less than in the 2.4 gigahertz band. So when dealing with corporate environments, it's really easy to design for 5 gigahertz because you're going to have small cells that will be able to serve all your clients, because 5 gigahertz, depending on the case, will not reach as further as 2.4 gigahertz. So designing the smaller cells for offices will be easier than designing for 2.4 gigahertz. Something I also want to say is that, as you can see in the picture, the 2.4 gigahertz band, it was just designed this way, but just as Manon mentioned in the first slides, we have 3 non-overlapping channels, which are 1, 6, and 11. And whenever we have an office deployment, as a good practice, we should be just using these channels. But the problem with this is that because of the 2.4 band covering more area than the 5 gigahertz band. These radius of the AP are going to reach much more further than the 5 gigahertz radius. So one of the best advice that I can give everyone here is to lower their power in order to reduce their cells and don't have co-channel interference, even adjacent channel interference. In high density deployments, I'm really a big fan of turning off radios. I don't like to lower every AP radio because the wireless environment always changes. So I'm not a big fan of lowering too much your power. It helps, but I would rather just turn off the radio. I'm not sure if Manon could give us her opinion on this.
Okay, so yes, designing for 5 gigahertz is a good idea if your clients support it. If your client mix is comprised of AC clients, you can be sure that they support 5 gigahertz because AC was only was specifically targeting 5 gigahertz. Now, if your mix of clients does offer 5 gigahertz, designing for it is a good idea. 5 gigahertz is more sensitive to a variety of well, I'm trying to stick to the basics and tell you it's not really that 5 gigahertz cannot travel as far as 2.4. It's more than that. How can
attenuation affects it more than in
yes,
2.4.
attenuation affects it more. It's a higher frequency, and also an antenna is just the metal element, right? And it can catch any kind of frequency. Now to tune it to receive the 5 gigahertz appropriately, it's going to require a much more, the target is going to be a little bit smaller, and that's why we get the impression that it does not travel
as further
as further as a 2.4. Now, nowadays, a lot of manufacturers, and I'm a big fan of that, offer antennas which allow you to use a flexible antenna. I hate to waste radios, so turning them off, I think, is a good choice in 2.4, but I would much rather order a bunch of dual 5s so that I can, I'll make sure that they're separated in their channel allocation, but I would rather have a radio that has 2 5 gigahertz radio elements in there than turn off a 2.4. But that's
exactly.
that's my taste. Now, yes, once 5 gigahertz works, you can design for 2.4. But the two things that you have to keep in mind: ACI, CCI, co-channel interference, adjacent channel interference. Bear those in mind. Anyone can have a predictive survey in Ekahau and make it green, but is it really good? That's the other question.
Yeah, totally. Well, moving on. We're close to the end of this webinar. Something that some wireless new engineers don't do is to measure their materials. They just use the defaults that come with Ekahau, and in my experience, that's just always going to end up in trouble, because you might be able to have a drywall wall in your facility, but the problem is that drywall wall might be hollow or might have a metal mesh inside of it, and then its attenuation is going to vary. and also
I
in
mean, sometimes
Mexico.
in educational buildings and hospitals, maybe your drywall, there's a building code specification that makes you have 2 sheets of drywall, and so you think it's only one, and the wall is hollow, and so you're thinking it's 2 dB attenuation, but really it's 4.
Exactly. Also, here in Latin America, we tend to have like really old buildings. Uh, Even though you could have sworn it's concrete, it's concrete reinforced with metal pipes, and it
And
just
then
gets
you've got
worse
some
from there.
cement, and then you've got some plaster and terracotta and all of that. Yeah, we do
Exactly.
have some old buildings up here too. Would you like to
Okay.
say a word on measuring the free space measurement? I think that it's really important.
Yeah, if you can help me out explaining the the drawing, that would
Okay,
be really nice.
of course. So the way I do it, and I'm basing myself on your picture, but it's slightly different. So the way I do it is using an RF measuring device, such as an NetAlly air check. Which is a very precise RF measuring device. I will place my AP at a certain distance, 5 meters is good, and I'm going to take in free space, so no obstructions whatsoever, I'm going to take a measurement of the RF power that I get. Now, if I go and add the obstruction, say the wall or the window or the door, and I take the same measurement for the same distance, then I'm going to get the attenuation value for that wall. And then when I go into Ekahau, you can personalize your walls, and you can say, well, this type of wall has minus 2 dB, this uh, wall de la muerte is minus 35 dB, and then you've got this glass door or this fire door that's like minus 15, and that's going to give you a much more precise prediction, because the values in Ekahau are just well, they're not random, they're just average values, and they can very well differ from what you're
Exactly.
facing.
Exactly. All right. I did record a video for everyone to see, but the problem is that we are already out of time. So what I'm going to do is to spook everyone and to also upload the video to YouTube so that you guys can see it. I'm really sorry I didn't think it would last so long, this webinar. But anyway, something I want to advise to all our viewers from Latin America is that we'll be hosting here in Sama Wi-Fi an extra troubleshooting class in Mexico City if you guys would like to join us. Fernay Munoz, a CWNE, a friend of Manon and I, will be giving this class. I swear it's nothing
In
that you have
Castellano?
already seen in the wireless industry.
Huh?
Yeah.
In Castellano?
Yeah, in Spanish.
Yes, awesome. Fernay's
So
a Colombiano, and he's an awesome guy. He's an ECSC instructor for Ekahau. He's awesome, and the troubleshooting class is the latest that they've come up with, and I've heard very good things about it. So if you want to start your journey into learning the Ekahau tool, that's a very, very good one to start with.
yeah, we'll be also giving wireless WLAN pies for everyone. I even bought one already. So if you guys want to join us, that will be awesome. These devices are new to the wireless community, are really good for troubleshooting.
They're really handy based on Raspberry Pi units. They're very portable, and you can do all sorts of things with them. They're actually, if you want to look them up, I think it's WLAN.pi or something like that.
Yeah.
And yeah, there are all sorts of tools. I'm really excited for that class.
Yeah, so for all our LATAM viewers, please stay up to date in our social networks, and we'll be releasing the precise set of this course that Ferney will be hosting.
And I think that you have something in store for a WLPC LANTAM day, design day, or something like that. So if ever you get the chance, I'm sure that Elliot will be very glad to have you at that event, right?
Yeah, we'll be hosting a design day for Ekahau. Also, stay up to date in our social networks so that you guys can see when that happens. And well, I think that you wanted to mention something for the Canadian viewers.
Yeah, well, the Wi-Fi community is an awesome community. I've said it many times, and every single time I get the chance to speak in webinars and in conferences, I mention it. So um, if you can, try to learn as much as possible. There are awesome resources. There's Revolution Wi-Fi, Andrew Von Nash, who gave so much to the community. There are lots of podcasts. I'm thinking of the Contention Window. I'm thinking of Mobility Field Day, who's hosting awesome events. There are lots of resources, and I can understand that. Granted that you guys face the same situation as I do, whereas I'm a native French speaker. You more than likely are native Spanish speakers. These events are all held in English, but they're very considerate of the fact that it's not everybody that speaks English, so they're going to take the time to explain to you. We also have Slack groups. If ever you want to get on the Wi-Fi Slack group, tell Elliot, tell me, and we'll get you hooked up. And get on Twitter. You're going to learn so much, and you're going to learn about new blogs and new podcasts and events. And there's WLPC US that's coming in February, and so many awesome things that you really have to learn more about this awesome community. So, and then the second step is to give back. Pay it forward.
Thanks, everyone. Well, I'm not sure if someone has a question. If so, you can type those in the chat. We can give a few minutes if you feel comfortable with that, Manon.
Yeah, sure.
Okay. So, do you already have your wireless? No, your WLAN Pi?
I do. I have actually. I have so WLAN Pi started on the Odroid platform, and then it was migrated to the WLAN Pi platform, and I have both. And I love the WLAN Pi way much more than the Odroid.
You see, I have both. I have not gotten my WLAN Pi. Ferney will be delivering to me today. I bought it from him, but I have an Android too, and it's just way much better, the WLAN Pi.
So is he shipping it to you, or he's in Mexico today?
He's coming today.
Oh, awesome. It would have been nice to have him on. I'm sure he would have had great recommendations for your viewers.
Yeah, the thing is that he'll be arriving slightly late today.
Oh, okay. Well, next time then.
Next time. Well, I think we don't have any questions at the moment. Anyway, this webinar is going to be recorded. It's being recorded actually. So if anyone happens to have a question, here I'm leaving to you the email of Sama Wi-Fi if you're also interested in purchasing Ekahau. We are distributors. And c'est la vie. Would you like to add anything else, Manon?
Not really. I mean, these are the basics. There are awesome training opportunities with Ekahau. You've heard about ECAC troubleshooting. They also have two other ECAC classes, the classic and then the advanced. So I'm sure that if ever you request one of those classes from Elliot, he'll make sure to that it reaches the right ears at Ekahau, and you can have an instructor, whether you like an instructor that speaks very good English or very good Spanish, they all have them. And they may even have one that speaks Portuguese if ever you're so inclined. So don't miss them. They're awesome. I've taken them and I've been using Ekahau for a lot of years, and I took one last year, and even if it was the basics and I knew a whole bunch of stuff, I still managed to learn a couple of neat tricks. So don't miss it. And thank you, Elliot, for having me over.
No, thank you for helping me.
Pleasure.
Well, all right, we'll chat later. Thanks, everyone. I'll be closing this session. I hope you really enjoy it. And look out for more news. We might have Manon again if she'd like to. So stay up to date in our wireless networks.
Goodbye now.
Bye bye.